Hey, Year 7s. Okay, today we're working on something called the distributive law, or the distributive property. But you won't often hear it called that. Usually you'll just hear it called expanding brackets, which means getting rid of brackets in an algebraic expression that contains brackets. Okay, so our learning intentions are to expand brackets with algebraic expressions using this law, and to understand how this law can be applied to multiplying large numbers. Okay, so the question is, what is the law? Well, the distributive law says the following. When you have the sum of two things, let's call them B and C, and they're in brackets, and then the sum of those two things multiplied by something which is outside of the brackets, okay, and you remember your BIDMAS rules, the sum happens before the multiplication because the sum is inside brackets and brackets come first, then this is equal to A times B plus A times C. See? A times B plus A times C. Now that's not entirely obvious why that is the case, but I can make it obvious by showing you something really simple. Let's forget algebra for a second, and let's just look at standard numbers. Okay, on the left, 6 bracket 8 plus 2. If we were asked to evaluate that, what we would normally do is evaluate the brackets first. So 8 plus 2 is 10, and we would get 6 times 10, which is 60. But it turns out there's another way you can do it. This is a positive 8, there's an imaginary plus sign there that we can't forget. So positive 6 times positive 8 equals positive 48. Now we do positive 6 times positive 2, which is positive, so I'll write a plus sign, 12. 48 plus 12 is 60. So both of those methods work. Now, when it comes to algebra and on the inside of the brackets, you have a sum that you cannot evaluate. 8 plus 2 equals 10. X plus 2, well, that just equals x plus 2. So only one of these two ways is going to work for us to get rid of the brackets. And it's not this way, because this way requires that we first add these two things together. But we cannot do x plus 2, find the answer to x plus 2, and then multiply it by 6, because x plus 2, they are not like terms. They cannot be added. So we have to use the second method. Positive 6 times positive 1x, we get 6 times x. Now positive 6 times positive 2 is positive 12. 6 times x is 6x plus 12. So you can get rid of brackets in algebra, but you have to use this method, okay? So 6x plus 12 is exactly equal to this thing here. That's called expanding the brackets. And that's why this law here works. Okay. Now, just to get things started, there's actually a very clever way that you can use this law, this distributive law as it's called, to solve some pretty large multiplication questions. For example, 4 times 98. Well, that is the same as 4 times 100 minus 2. We can tell that 98 is close to something like 100 or 1,000, okay? All right, so now it's simple. We do positive 4 times positive 100, which is positive 400. Positive 4 times negative 2. That negative belongs to that second term. Positive 4 times negative 2 is negative 8. 400 minus 8, simple calculation, 392. So that's a little bit easier than trying to do 4 90s and then add on 4 8s, isn't it? Nice little strategy for you. Here's another example over here, 22 times 1003. Well, what about we rewrite that, I've got my equals over here, as 22 times 1000 plus 3. Now, positive 22 times positive 1000 is 22,000. Positive 22 times positive 3 is positive 66. So we get 22,066. So the that's how you can use the distributive property to find some rather large multiplications quite quickly. It's a trick that sometimes works. And there's the proper setting out. But you won't be doing much of that. We do the distributive property in the context of algebra, okay? So we're going to do some practice problems. Expand the brackets using the distributive law. Okay. So thing outside times first thing inside, then the thing outside times the second thing inside, including the sign that comes before it. It's the number one thing students forget, okay? So 5 times, let me zoom in maybe, 5 times A. I could write 5 times A, couldn't I? But why not just write 5A? 5A. Now 5 times the second thing inside the brackets. 5 times negative 2. Positive times a negative is a negative. 5 times 2 is 10. So we've expanded the brackets. Simple as that. Okay, what about over here? Positive 7 times positive 2h. Well, positive 7 times positive 2 is 14. And we have an h. Now, positive 7 times positive 3. 2 positives make another positive. 7 times 3 is 21. Simple. Okay, let's move on. They're the solutions. All right, a little bit trickier now. Expand the brackets. So 2a multiplied by a. Well, maybe I'll write it all out properly this time. 2a multiplied by a. Okay, so the first thing outside the brackets multiplied by the first thing inside the brackets. Now the thing outside the brackets multiplied by the second thing inside the brackets. Deal with the numbers first. So, well, actually, I'll just write. So 2a times 3b. And it's a positive and a positive, so it's going to be plus. The 2 and the 3 we can put together. 2 times 3, ab. And we get 2a squared. A times a is a squared. Plus, well, 2 times 3 is 6. 6ab. Okay. Let's do another one. Minus 3 times 9m. Minus 3 times 9m. Now minus 3 times minus n. Minus 3 times minus n. All right, well, multiplication comes first. Minus 3 times 9m. Minus 3 times 9 is minus 27. And we put the m there. Now minus 3 times minus 1, which is in front of that n. Okay. Don't forget that a minus sign really means minus 1. So minus 3 times minus 1 is positive 3. And we have an n there. So minus 27m plus 3n. It's tricky, guys. And we're going to have a session next week where we actually live. I'll give you guys an opportunity to ask a bunch of questions about some of these things, okay? All right, and that is the end. One thing I just noticed, guys, is this here is a different problem from the one that I did here, because this is missing a squared, but that's okay. Have a look what's happened here. Here we had 2a squared times a, 2a squared times a, and then 2a squared times positive 3b. So plus 2a times 3b. And then 2a squared times a to the power of 1. You add the powers, don't you? And you get 2a cubed plus 2 times 3, which is 6, ab. To get this here, 6ab. All right, so that's expanding brackets. I know it seems a little bit hard, but once you've done a few more of these, you'll start to get the hang of it. But I don't expect anyone to fully understand it right to begin with, okay? All right, thanks for listening, guys. I'll catch you later.